Hello, everyone. In this lecture, we're going to talk about the test on the population variance. Because in the previous lectures, we test on the mean, right? Either a single population mean or the difference between two population means. Now, what about we have a population? We want to know a little bit more about the variance based on the data. So let's do this exercise together. So an automated filling machine, like the Coca-Cola, right? They fill a lot of bottles with the cola. And we use the automated filling machine to fill the bottles with Coca-Cola drinks. Now we take a random sample of 20 bottles and it results in a sample variance of fill volume. This is the sample variance. Now, if the variance of the fill volume exceeds 0.01, then an unacceptable proportion of bottles will be underfilled or overfilled. So can we understand why? Because the variance is bigger, then you will sometimes you go higher, right? And you fill a lot of cola drinks, and then you will spill the drinks out, and this just they were out on the production line. All the underfilled, your customer won't be happy. So is that evidence? So you don't want the variation to be big, but you know the sample variation, samples variance, but you don't want the variance to exceed 0.01. Now, based on this data, you have 20 bottles. Is there evidence in the data to suggest that the manufacturer has a problem with underfilled or overfilled bottles? Use alpha equals to 0.05 and assume the fill volume has a normal distribution. Okay. So if the fill volume has a normal distribution, now you take the sample, you're getting the variance. Then the variance will have a chi-square distribution. We're going to try to get the chi-square distribution. Because now, the null hypothesis, this is the general procedures. You see, this is the chi-square distribution. And this is upper tail. If you have alpha over 2, this location is chi-square alpha over 2 and minus 1. And however, for this location is chi-square 1 minus alpha over 2 because you have alpha 2 over here, but all the way to the right side, there are 1 minus alpha. 1 minus alpha over 2, okay? So this is why this is chi-square 1 minus alpha 2, because the more you left in the right side, the smaller you are, okay? And the smaller you have this small area, then this is bigger location. And for one-sided test, you only consider alpha. You don't split on both sides. But if you consider two-sided test, then you have to because sometimes you can have a two-sided test. You can have equal to or that's not. So two-sided test. This is two-sided. This is right-sided. This is left-sided. So for two-sided, you could potentially be bigger or smaller. So that's why you could be in the other side. This is a little bit different from the T distribution and from the Z distribution. So the rejection criteria, if you are in this region, you reject. If you are in this region, you reject. So that's why greater than or less than this one. However, for this one, if you, for one-sided test, you just greater than this one, you will reject. Or you're reciting over here, you reject. So those are the rejection criteria. Reject what? Reject the null hypothesis. If this is satisfied, and then you reject the null hypothesis, and then alternative hypothesis is valid. Now, instead of just talking, let's do this exercise. So first step 1, formulate hypothesis. So null hypothesis, sigma square equals to 0.01, always equal. Alternative hypothesis is greater than 0.01. Now, second step, compute the test statistic. So we will have chi-square 0 equals to m minus 1 s square over sigma square. And this is sigma 0 square because we're testing against point 1, right? Square. So this will equals to, the variance. This is 0.01. So n minus 1, so we have 20 samples. Minus 1 times the variance, 0.053, then 153, then this equals to 29.07. 29.07. So based on the rejection criteria, we are going to reject H naught if chi-square is greater than chi-square 0.0519, because 20 minus 1, this we don't split on both sides. However, this equals to 30.14, and step 4, our chi-square 0 equals to 29.07, which is less than 30.14. So we cannot reject H naught. So we conclude there is no stronger evidence that the variance of the field volume exceed 0.01. So we are safe. We don't have underfield or overfield problems. Okay. So this is the end of this exercise.